Hi, the goal of this submodule is to increase awareness and user uptake of Copernicus products and services related to the coastal and marine areas, showing how they can be used to generate added value information useful for public and private decision makers. The added value product based on Earth observation data and services we are going to show you are assessment of marine food provision, ecosystem services, and potential aquaculture site. The proposed assessment can help you take a decision dealing with problems related to the coordination of maritime uses, as required by the Maritime Spatial Planning Directive, and to sustainable development and growth of the maritime and coastal economies. In particular, this demonstration focuses on the quantification of marine ecosystem services in terms of food provision, fisheries, and aquaculture, and the conservation and protection needs of coastal and marine environments. Having a look at the real world, use case 1 introduces the marine food provision assessment by identifying sustainable fish growth condition site scenario and by estimating among these sites the potential fish growth rate. As a use case for food provision assessment, we selected the Mediterranean Sea, which, characterized by a high vitality, is central to the interest of several countries and several strategies related to the environment, economy, and politics. For example, fisheries will benefit greatly from added value information in order to optimize its strategies on the basis of analysis driven by the biophysical parameters. This would be, for example, getting a deeper knowledge on where and when there is a higher probability to find fish biomass, helping local fishery companies to organize their activities in order to maximize the harvest, and harmonizing economic strategies at a local level or in cross-border framework, for example, a shared marine basin like the Adriatic and Ionian Sea. From a biophysical point of view, as it can be seen from the Copernicus Marine Service temperature animation, this sea shows seasonally different behaviors in the western and the eastern parts of the basin, and the same situation also emerges when looking to the other parameters. This suggests, therefore, that strategies to be applied for the exploitation of marine resources, the achievement of conservation goals, or the definition of economic policies should be based on spatial and temporal assessment over very large areas. As we are going to show you shortly, Copernicus products and services already available or under development can provide a valid support to this assessment and can be differentiated according to detected conditions to both spatial and temporal assessment. To assess food provision, we selected fish species, for example, sea bass and sea beam, but indeed they can be substituted with any other kind of fish or other element representing food, and the relevant parameters to characterize fish vitality condition. Among the available products and data provided within the Copernicus program, those used within the food provision assessment belong to the Copernicus Marine Environmental Monitoring Service. The products are available on a free, full and open basis on the dedicated website. Use case shows how Earth observation-derived products can be exploited as stand-alone approach, but to fully exploit their potential and take advantages of already collected data and products generated from other sources but satellite, analysis combining them are highly recommended. The development of the assessment we are presenting requires two main kinds of knowledge. One, strongly related to the discipline's environment field to which the product refers to, like fish vitality range for selected parameters and the definition of the threshold value for acceptable water condition. For example, for the assessment of the fish growth, the mathematical formula has been customized for selected species. Another one type of knowledge, which is more technical and necessary to deal with spatial data in different formats, as well as other kind of data, and to perform several kinds of analysis such as spatial and temporal analysis. The Earth observation derived products used for the assessment are sea surface temperature, current, salinity, dissolved oxygen, pH, nutrients, and chlorophyll A, all available from CMEMS service. On the other hand, the tools used are a software for spatial and temporal analysis and a software for NetCDF data for management. By observing the animation of the temperature trend for the year 2012, we noticed that, according to the temperature depth range from 30 Celsius degree, both Adriatic, Ionian and Aegean Sea can be considered sea acceptable for the two selected species, sea bass and sea bream. Additionally, by observing the animation of the chlorophyll A trend for the year 2008, we noticed that chlorophyll A concentration confirms that dual character of the Mediterranean Sea basin that is more oligotrophic in the eastern part than in the western one. The final product of the assessment are two maps representing the potential food provision services associated with the selected fish species in terms of their annual growth in grams. Look at the marine food provision from another perspective. We could be interested in evaluating acceptable water conditions, not searching for natural available biomass, but with the intention of producing biomass, for example, within an aquaculture plant. The potential aquaculture assessment is aimed at considering the actual competing uses of the maritime space, identifying sites with conditions feasible for aquaculture fish growth, the feasibility scenario, assessing different productivity performance of these sites in terms of potential fish harvest, the suitability scenario. Added value information from Earth observation data would greatly benefit aquaculture strategies at national policy level, as well as the level of single private entrepreneur by first, enabling, for example, the comparison of different fish species, or understanding which sites are more suitable according to fish cages constraints and taking into account potential fish harvest. Northern Adriatic Sea is an overcrowded basin in which competing uses are continuously growing, and therefore an overview of them is needed not only in the perspective of a national organization of maritime uses, but also in the view of a transnational cooperation. Moreover, the increasing demand for food is pushing the development, wherever possible, of aquaculture, and the Food and Agriculture Organization has suggested sea bass and sea bream as the most common native species in European marine aquaculture for the Mediterranean Sea. Here the assessment is based on the products provided by the Copernicus services, combined with other non-European Earth observation programs like MODIS, Ocean Color, products that belongs to NASA. All the other observation products used for the analysis of the potential aquaculture sites were downloaded from the links shown in the slide. And ancillary data to perform the assessment have been also taken into account. They can come from different sources, for example, the European Marine Observation and Data Network, EMORNET, regional data repository, and research institution. And they can be the result of models run using Earth observation products. As for the food provision assessment, here also two kinds of knowledge are put in place. One strongly related to the discipline environment field to which the product refers to. Along with the threshold value for acceptable water condition for fish growth, indeed also information related to minimum environmental requirements for plant cage functioning are required. Cage's depth, minimum current water turbidity limits with regard to anoxia event. Another more technical knowledge is needed to perform and enable spatial and temporal analysis. The Earth observation products used are sea surface temperature, total suspended matter, color dissolved organic matter, chlorophyll A, and currents. The tools used are a software for spatial and temporal analysis of data and a software for the management of NetCDF format. The approach we developed to assess potential aquaculture site is summarized in the form of a flux diagram shown in a slide in a very simplified manner. with all the steps to be performed on products and data. The result of the process are two assessment maps: a feasibility scenario, identifying sites with conditions feasible for aquaculture fish growth, and a suitability scenario, assessing the different productivity performance in terms of potential fish harvest of feasible site. The assessment results represent products that give really an added value information over a very large area and in a selected period of time that could be of interest of public and private decision makers to define policy, economic strategies, and future investment. This kind of overview could be difficult to be obtained using other kind of source data, but Earth observation data. The use of Earth observation data combined with in situ and ancillary information is a good compromise among area extent, degree of information, detail processing, and time and effort. Even if specific and technical knowledge are required, the availability of already financed Copernicus products and services have a great potential to help you answering several issues, a potential that is waiting for you to be fully exploited. Thanks for your attention.